Good day, everyone. I will be discussing Chapter 4 or the resultants of the force systems. Upon looking at your syllabus, this topic is still under Chapter 2, but there are certain topic kasi that we need to discuss first under Chapter 3 bago natin maintindihan yung concept ng resultants of force systems. That's why there is a certain revision of our syllabus. So, ang Chapter 4 na natin is the resultants of the force systems. Okay? So, let us define first or discuss yung mga terms here that I believe na most of you is not familiar, okay, or wala pang background on these terms. Okay, unahin natin yung moment of a force. Moment of a force. So it is the tendency of a force to rotate the body on which it acts about a given point or axis. So involved na dito yung rotation of the body. Okay. We have also the moment arm or the lever arm. It is the perpendicular distance from the point or axis to the line of action of the force. And next is the moment center. It is the point where the body rotates or tends to rotate. Okay. So meron tayo ditong illustration for us to visualize kung ano yung ibig sabihin ng mga terms na to. Okay, so we have here an illustration. Let's say this is the particle, this one. Yan yung particle natin. And then if we applied a force F here, okay, we applied a force F here, it will tend to rotate the particle or the body. Dito na tayo nga nagkakaroon ng tinatawag nating moment of a force. There is now a rotation if we applied a certain force on our particle. So the distance here is what we call the moment arm or the lever arm. So this distance D here is perpendicular from the point or axis of the line of action of the force. So ito yung ating force, no? Ayan. Ito yung ating force. So this is our force F here, no? So yung line of action nito is ito, di ba? So extend natin yan ng extend, and then we will find the distance that is in perpendicular to our moment center. So ito yun. Ayan, yan. Perpendicular yan from our moment center to the line of action. Therefore, our moment now, or yung pinaka-formula natin for the moment is equal to the force applied multiplied by the distance that is perpendicular to our moment center. So again, ang concept nito, if we apply a certain force to our particle, it will tend to rotate. It will tend to rotate the particle. Okay, so for example, yan yung particle natin, nag-apply tayo ngayon dito ng force F. So yung ating body will now rotate. Iikot yan ngayon. Iikot tong ating particle. Okay. And then yung ating force D now is, yan, i-extend natin yung ating line of action ng ating force. And then, nahanapin natin ngayon from the center, moment center, yung perpendicular distance. Yan na ngayon yung ating tinatawag na moment arm or the lever arm. Okay? So, tandaan natin to, moment is equal to the force multiplied by the distance or yung ating tinatawag na lever arm. So, this is very crucial on the next chapter, the analysis of trusses. Okay. So we will be utilizing more on the moment of a force. Okay? So kailangan nating intindihin yung topic na to maayos para mas mapadali yung discussion natin on the next chapter. Okay? Meron tayong tinatawag na Varignon's theorem or principle of moments. The principle of moments states that the moment of a force about a point is equal to the sum of the moments of its component about the same point. So, proceed tayo dito ngayon sa illustration na to. Ayan. We have here an illustration of a resultant. Resultant R. Ayan. Ito yung ating resultant R. So, meron siyang component A and component B. Sabi natin kanina, if we want to find the moment of a certain force, kukunin natin yung distance that is in perpendicular to that force. For example, this one, yan, yung resultant R natin, yung red. The distance perpendicular to our moment center, yung moment center natin is yung point O, is the distance D. Moment center, this is the force R, and the distance that is perpendicular from the line of action of our force R to the moment center is this distance D. So, sabi niya, express natin yung ating resultant into its components. So, yung components niya is component A tsaka component B. If we have our force A here, extend lang natin ng extend yan. Kaya nga meron tayong line of action. Hahanapin ngayon natin yung distance that is perpendicular to our point O. So, we have our distance A. So, perpendicular yan. Perpendicular yan yung ating point D, force R to our distance D. And then, for our component B, ayan, or our force B, yung kanyang distance that is perpendicular to our moment center is our distance P. So, 90 degrees din yan. So, yan yung mga lever arm ng ating mga forces. And we have here our alpha. Yan. The angle between our x-axis to our component A, alpha. We also have our gamma. From the x-axis papunta sa resultant is our gamma, and we also have our beta. Inclination from our axis to our force B. And if we get our distance here, okay, we have force B, ayan, force B cosine beta. So, yun yung distance, diba? Triangle yan, no? This one is the triangle. So, we have here B cosine beta. And then this one naman, ayan, yung ating alpha. This 1A, ayan, force A natin, diba, is also equal to our force A here, tama? Ayan. Force A yan, force A din dito. So, same sila ng ating inclination. If we have alpha here, we also have here our alpha. Ayan. Therefore, this is now A cosine of alpha. This one. A cosine of alpha. Okay? And then the whole distance here is our R cosine of gamma. Okay? R cosine of gamma. So the principle of moment states that the moment of a force about a point to the sum of the moments of its the moment of a force about a point is equal to the sum of the moments of its component about the same force. So this one is the moment of our resultant. So the moment of the resultant, ang sabi natin kanina, we have the force multiplied by the distance. So ano yung force natin? It is the resultant. Ano yung distance that is perpendicular to our moment center? We have D. Kaya meron tayo ditong RD. Or express natin dito in terms of H and gamma. So we have here H cosine gamma. The D here is what? Yan yung D natin. D. We have H. Yan H. Cosine of gamma. Okay? And gamma. And then for the moment A, it is force A multiplied by the perpendicular distance A, and moment B is force B multiplied by the perpendicular distance B. The moment of a force about a point is equal to the sum of the moments of its component about the same force. So, express lang daw natin yung components ng ating resultant R, and then kukunin natin yung individual moment nila, and it is also equal to the moment of the resultant. Okay? The moment of a force about a point, which is the moment R now, yan, moment R, the moment of a force about a point is equal to the sum of the moments of its components about the same force. So, ano ba yung mga components niya? We are the moments of the components. We have the moment at A and then moment at B. So, MR is equal to the moment at A plus moment of B. Okay? So, yan yung Varignon's theorem or the principle of our moments now. Next, we also have the principle of transmissibility. So the principle of transmissibility states that the conditions of equilibrium or motion of a rigid body will remain unchanged if a force F acting at a given point of the rigid body is replaced by a force F prime of the same magnitude and same direction, but acting at a different point provided that the two factors have the same line of action. The principle of transmissibility states that if we have here a force F, ayan, force F natin, kunin natin yung line of action niya, which is this one, di ba? Line of action, ayan, hanggang dito, extend, extend, extend. Pwede rin dito, extend, 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 extend. So, if we have a force F here, and then, we also have force F prime here, replacing our force F with force F prime here. As long as they lie on the same line of action, their magnitude is still equal. Okay? Ibig sabihin, if we have a particle and meron tayong isang line of action, all throughout the line of action, we have a constant magnitude of force. Ibig sabihin, F now is equal to F prime. Okay? F now is equal to F. The conditions of equilibrium or motion of a rigid body will remain unchanged. And if a force F acting at a given point of the rigid body is replaced by a force F prime. So, remain unchanged daw. Ibig sabihin, F is equal to our F prime as long as they lie on the same line of action. Okay? To further understand the concept about moment of a force, let's have some problems. Okay? Determine the moment of force F, which is equal to 40I plus 80J Newton about point O. Hanapin daw natin yung moment of our force F about our moment or about our point O. So, yung point O na natin is our moment center. As we have defined earlier, moment is equal to force multiplied by the distance. So, maghahanap ngayon tayo ng distance that is in perpendicular to our moment center or our point O. Okay? So, una natin gagawin dyan is to find the component of our forces. So, we have, let's say this is Fy and we have the Fx. Okay. Sabi natin kanina, the moment of a certain force is equal to the moment of its resultant. Okay? Moment F is equal to the moment of its components, di ba? F5. Or we have Fx multiplied by the distance that is in perpendicular to our point O plus the force multiplied by the distance that is in perpendicular to our force O then. Okay? Moment at point O. Dito pala tayo nagmo-moment. So, we have moment at O. Moment about point O. So, hanapin natin what is the value of our Fx. Fx is equal to F 40I plus 80J or we have 40 Newton, di ba? And then Fy is 80 Newton. Now, hanapin natin yung distances nila that is in perpendicular to our point O. So, for our D1, it is Fx, perpendicular distance to our point O. Ito yan. So, we have 150 millimeter. We have 150 millimeter. And then, for our distance to Fy natin to, Fy. So, the force that is in perpendicular to our point O is what? 360 millimeters. 360 millimeters. Okay. So, meron na tayong given here. And take note that our sign convention here is lahat ng clockwise is positive and then lahat ng counterclockwise is negative. So, imagine natin dito, we have here our force Fx. So, time to substitute, okay, Fx. So, we have here 40 Newton and then D1 is 150 millimeters. Now, paano natin i-determine yung rotation? So, tingin tayo dito sa Fx natin, Fx. Yung Fx natin, di ba, a principle of transmissibility, lahat is equal yung forces on the line of action. So this is also our Fx. So imagine natin, this is our force. And then, dung paran na kumadetoy, 150 millimeters tayo dito. Okay? So babanggain niya ngayon yung 150 millimeters and it will create what? It will create a clockwise motion. So for example, this one is a stick. Example lang this one is a stick. We have a force Fx here. So, pag in-apply natin yung force Fx natin dito sa 150 mm stick natin, magro-rotate yung stick natin, di ba? Into what? Into a clockwise motion. Therefore, positive ngayon to. Okay? Positive. Next, proceed tayo sa Fy dito. Fy is we have 80 Newton. The distance is 360 mm. So, paano nga yung magiging rotation naman ng ating Fy? Fy ito, di ba? Fy. Yan, yung Fy natin. Also, Fy din to, di ba? Fy din. And then, imagine natin, stick ulit to. Stick, 360 mm length of stick. A-apply ngayon natin siya ng force Fy. So, babanggain ng force Fy natin yung end of 360 mm. So, anong mangyari sa 360 mm? It will tend to, what? Rotate in a counterclockwise direction. So, ikot ngayon yung ating 360 millimeters. And yung magiging center niya is, of course, our point O. Dito ngayon siya. O, pwede rin dito. Okay? Kasi perpendicular distance. Yung ating 360 millimeter will now rotate in a counterclockwise motion. Therefore, this will be equal to negative. Okay? Negative. Kasi it will tend to rotate it in counterclockwise motion. Negative 80 multiplied by 360 millimeters. So this is now equal to 22,000. So we have 22,800. This was is in Newton. Tapos ito is millimeter. Newton din to, and then this is millimeter. Therefore, this is equal to Newton dot millimeter. Okay? Newton dot millimeter. Or, if you want to express it in Newton dot meter, okay, 22,800 Newton dot millimeter. So, this is just equal to, this one is 1,000 millimeter. And then 1 meter, we have 22.8 Newton meter. Okay? So, this will be the final answer. The moment about point O is 22.8 Newton millimeter. Okay? This is the first step. Meron din tayong second solution for this one. This is the first solution. Present natin yung second solution. So there are many ways in computing for the moment of a certain force to the moment center. So for our second solution, we will be using the normal and the tangential components of our forces. So pag sinabi natin tangential tsaka normal, kukunin lang natin yung equivalent tangential force and the normal force of the given force. This is our force F. So pag sinabi natin tangential, yung force natin is lying on the line of action of our maglalay yung ating force into a certain axis. Okay. So this is our tangential force, and then we also have a force that is in perpendicular sa ating, mahirap mag-drawing dito sa tablet. So this is our force N, or the force that is in perpendicular to our axis. So yung axis natin is this one. FP tsaka FN. So yung slope natin dito, we have here 360 tsaka 150. And then dito kanina, we have our 40i tsaka 80j. So yung kanyang x axis is basically 40. Tapos yung y-axis niya is 80. Okay? So, yan yung kanyang slope. 40 tsaka 80. So, assume natin that this is our theta. Theta, ayan. Between Ft tsaka yung ating force F. So, our theta is equal to tangent or arctangent of 80 divided by 4 minus tangent, arctangent, or inverse tangent of 150 all over 360. So, theta now is equal to so it is equal to 40.82. 40.82 degrees. 40.82 degrees. Okay, so compute now for the magnitude of our F. So we have here square root of 40 squared plus 80 squared. So this is equal to 89.44 Newton. So we have 89.44 Newton. Ang sabi natin kanina, the moment of a force is equal to the moment of its component. So, ano yung component ng ating force? We have Ft tsaka Fn. So, the moment about point O is equal to Ft multiplied by yung distance that is in perpendicular to our moment center plus what is the other component? Fn. And then the distance that is in perpendicular to our moment center. So Ft is what we have here, 89.44 cosine of 40.80, diba? Ft natin is 89.44 cosine of 40.82. So, ano yung maging distance ngayon yan? That is in perpendicular to our point O. So, the distance that is in perpendicular to our point O is equal to 0. Bakit 0? So, this is the line of action of our force T. Kahit i-extend natin yung i-extend, hindi tayo makakahanap ng any distance perpendicular to our point O. Kasi ito na mismo yung ating line of action ng ating Ft. So, walang any distance perpendicular to our point O. So, yan yung tatandaan niyo. If we have a certain force lying on the same line of action of our moment center, yung kanyang distance perpendicular will be equal to 0. For example, we have here a particle. Ayan, a particle. So, pinapahanap yung moment at this point. Ayan, moment at this point. And then, we have a certain force that is acting here. Mismo dito, magka same line of action yung ating force tsaka yung ating point O. So, ano ngayon yung magiging distance that is perpendicular to our point O? Di ba wala? There is no distance perpendicular to our point O. Therefore, the distance is equal to 0. So, hindi tayo makakapag-create ngayon ng moment. Okay? Kasi wala tayong distance. Same principle dito. Okay? Plus, okay, dito na tayo, Fn. Ano yung maging Fn natin? We have F, 89.44 at sine of 40.82 degrees. So, ano yung magiging distance perpendicular to our point O? So, ito yung Fn natin. So, maghahanap ngayon tayo ng distance that is perpendicular to our point O. Di ba ito yan? This distance. That if we tend to put a force dito sa ating line dito, anong mangyayari dito sa line? For example, ililipat natin yung Fn natin dito. So, mababangga yung, mag-apply tayo ng force Fn dito sa tip of the line. So, anong mangyayari sa line na to? Di mo magro-rotate siya. magkakaroon ngayon ng rotation. So, ano yung rotation niya? The rotation will be what? The rotation will be counterclockwise. Therefore, this will be negative. Okay, negative yan. Negative 89.44 sine of 40.82. And then the distance is square root of itong distance na to. Ayan. Yan yung magiging distance to natin. So, it is equal to square root of 360 squared plus 150 squared. Okay? Therefore, the moment at O is equal to 9.44 sine of 40.8. So, it is equal to negative 22,800 Newton that millimeter. So, ano yung negative na to? It will signify that the moment is in counterclockwise motion, or 22,800 Newton that millimeter counterclockwise. Okay? So, this will now be the final answer. Or kung gusto niyo i-express into Newton that meter, okay lang din. 22,800 Newton that millimeter in counterclockwise direction, kasi negative yan. Okay? So, take note that if we want to use a positive here, dapat meron siyang certain direction. And if we want to retain the negative here, wag na nating ilagay itong direction na to. But for me, I prefer to express our moment into positive and then lagyan ng direction. So, sana ganun din yung sa inyo. Okay? So, let's make it fixed. Okay? Lahat ng moment will be in positive and then lagyan na lang natin ng direction. 22,800 Newton that millimeter. Okay, proceed na tayo sa next example. Determine the moment of 650 pounds force about points O and B. Determine the moment of 650 pound force about points O and B. So, we have here a force that is equal to 650 pounds. Kukunin daw natin yung moment at point O and moment at point B. Okay, so madali lang to. Unang gagawin natin is to express yung ating force into its equivalent components. We have, let's say here, our Fx, tapos our Fy. So, our Fx is what? 650 cosine of 28 degrees. So, that is 573.92 pounds, and then our Fy is 650 sine of 28 degrees. So we have 650 sine of 28. Therefore, we have 305.16 pounds. Okay. So, start na tayo to determine the moments at unahin natin yung point O. So moment at point O is just equal to fx multiplied by the distance that is perpendicular to our point O plus fy multiplied by the distance. Fx is 573.92 pounds. Ano yung magiging distance in perpendicular to our point O? So this one is our force Fx. Okay? So the distance that is perpendicular is what? This distance. Ito yun na. Itong distance na to. That is in perpendicular to our point O. Therefore, we have 4 inches. So ano yung magiging direction niya? So imagine natin ulit, we have a force F here. Then meron tayong stick. Ayan. So, pag nag-apply tayo ng force Fx at the tip of the stick, so anong mangyari sa stick? It will rotate on its counterclockwise direction, di ba? So, we have here negative kasi counterclockwise. Negative 573.92 multiplied by 4. Plus, yung ating Fy. Fy natin is 305.16 pounds. What is the distance in perpendicular to our point 2? Ito yung ating Fy. So, ano yung main distance? Ito, di ba? This distance perpendicular to our point 2. So, parang naghahanap lang tayo ng stick. Ang magiging tip niya will be the moment center. So, maghahanap ko ng parang stick na magro-rotate. So, if we have here a stick, okay, and then also Fy din naman to, di ba? Fy yan as we have the principle of transmissibility. So, if we apply a force Fy here at the tip of our stick, so anong mangyari sa stick natin? Magro-rotate din siya ng counterclockwise direction. So, ikot yung stick natin into its counterclockwise direction. So, we have here 10 inches. 10. Therefore, negative din to. So, it is equal to we have negative 5347, sorry, 5347. We have negative 5347.28 pounds dot inches. And negative yan, kaya magiging 5347.28 pounds dot inches in counterclockwise direction. So, that will be the moment at point O. Okay, so, tapos na tayo sa isa. Next, proceed tayo sa moment at point B. Moment at point B. Okay? So, we have here the point B. Okay, point B. So, na point B. Yan yung point B natin. So, ganun pa rin. Gagamitin natin yung Fx tsaka Fy natin. Fx tsaka Fy. Okay? So, we have here moment at B is equal to Fx, yung kanyang distance in perpendicular, plus Fy, distance in perpendicular. So, Fx is 573.92. Okay, point B tayo. Yan, point B. So, na yung magiging distance perpendicular to our point B if we are pertaining with force Fx. So, ito yung force Fx natin. So, again, gagawa tayo ng parang stick. Ang kanyang tip will be the moment center papunta sa tip ng force natin. So, ayan. So, ito na yung magiging distance in perpendicular to our point B. So, this is equal to 14 inches. And then, ayan. Mag-apply tayo ng force Fx dito sa ating stick. For example, here, anong mangyayari? We have what motion? Iikot yung ating stick into counterclockwise direction. Therefore, we have here negative. Okay? Next one, Fy natin is 305. So, 305.16. So, ano yung magiging moment? Lever arm natin or the distance. So, gagawa ulit tayo ng stick, parang stick from the moment center papunta sa line of action ng ating Fy. So, ito ngayon yan. Again, principle of transmissibility. This is also Fy. So, pag nag-apply tayo ng force Fy dito sa tip, magkakaroon ng counterclockwise direction. or counterclockwise motion yung ating stick. Iikot yung ating stick into counterclockwise direction. Therefore, what distance? We have 6. And it will be negative kasi nga there is counterclockwise motion. Therefore, it is equal to so we have negative 9865.84 pounds inches or 9865.84 pounds inches counterclockwise. So that is now the moment at P. Okay, so this will be our final answer. Moment at O and moment at point P. Okay, counterclockwise. Okay, so proceed na tayo sa next example. A Newton force is applied to the control rod AB as shown. Knowing that the length of the rod is 225 mm, determine the moment of the force about point. So, gamitin ulit natin dito yung tangential tsaka yung normal component of our force. So, pag sinabi natin ulit tangential, the force is lying to the axis. Yung kinukuha nating moment center. Okay, so ito yung magiging line of action. So, we have here our FT. Tapos, of course, the force that is in perpendicular to our rod. So, yung rod daw natin is in 225 mm or 225 mm lang. So, kunin natin yung equivalent magnitude of FT and FN. So, we have here, what? This is also this is 65 degrees. 65 degrees ito. Sorry. 65. Ito yung may 65 degrees natin hanggang dito. 65 degrees yan. Therefore, ang kinukuha nating angle is ito. Ayan. Tawagin nating theta. Itong angle nito. Hanggang dito. So, we have theta is equal to what? 65 minus 25 degrees. So, that is equal to 40 degrees na. 40 degrees. Okay. 40 degrees. Sige, basta theta natin is 40 degrees. So, FT, our FT is what? Is equal to F, yung F natin, 90 Newton, cosine of 40 degrees or 90 cosine 40. And that is equal to 68.94. 68.94 Newton. Then for our Fn, we have Fn, yan, Fn. We have F sine of 40 degrees. So we have 90 sine of 40. So we have 57.85. Okay, so meron tayong mga magnitudes ng ating mga components of 90 Newton. Sabi natin kanina, moment at P is equal to the moment of the components of the forces. So we have Ft multiplied by the distance in perpendicular to our point P plus Fn multiplied by the distance in perpendicular to our point P. So yung Ft natin is equal to 68.94. So ano yung magiging distance in perpendicular to our point P? Meron ba? So, ito yung ating FT, no? So, it lies on the same of action of our point P as I have presented kanina. Pag mga ganito, no? If we have our point P lying on the same line of action of the certain force, therefore, hindi tayo makakapag-create ng any distance in perpendicular to this point, diba? Dire-diretso lang yan, Therefore, the distance is equal to 0. Okay? What about Fn? So, ito yung Fn natin. Magmo-moment tayo sa point P. So again, this will be the distance kasi normal yan, 90 degrees yan. Therefore, Fn is equal to 57 0.85, the moment arm will be 225 millimeters. So, ano yun? Positive, negative? So, yung force F natin, let's say for example, nandito yung force Fn, principle of transmissibility. Itutulak niya ngayon yung ating length or yung ating rod into what? Into clockwise direction. Diba? Iikot yung ating rod pag naglagay tayo ng force dito into a clockwise direction. Therefore, it will become positive. Okay? Therefore, the moment at B now is equal to 13,061.45 Newton dot millimeter. In clockwise, positive kaya clockwise. Or, we have 13,061.45 13 pwede rin na 13.061 Newton dot meter. Okay, dot meter. So this will be our final answer. Okay, so proceed tayo sa next example. Determine the direction theta of the 40-pound force F so that F produces the maximum moment about point A. Compute the maximum moment. So, dalawang hinahanap dito. The direction theta. So, ito yung theta na yan. That will produce the maximum moment about point O. So, hanapin daw natin yung angle that will produce the maximum moment at point A. So, ito yung magiging moment center ngayon natin. Hahanapin natin yung theta that will produce the maximum moment about point A. Okay? So, we have here a force 40 pounds. 40 pounds. So, ang sabi natin kanina, that the moment force F is just equal to the moment of each component. Therefore, hahanapin ulit ngayon natin yung kanilang X and Y components. So, this will be our Fy and then this is Fx. Okay, so Fy is what? We have 40 cosine of theta. 40 cosine of theta. And then, yung ating Fx is 40. Ay, sorry. Fy is Fy is 40 sine of our theta and Fx is 40 cosine of theta. Okay. So, the moment at point A is Fx multiplied by the distance in perpendicular to our moment center plus Fy multiplied by the distance that is in perpendicular to our moment center. So, Fx natin, we have 40 cosine of theta. Fx yan. Fx cosine theta. So, kung mag-recreate tayo ng moment at point A, ano yung magiging distance in perpendicular? We have our 2 feet. Ayan. 2 feet. So, we have 2 feet. So, it will tends to, pag tinulak natin itong 2 feet na to, it will create what? A clockwise motion. Clockwise motion. Kaya positive to. Positive 40 cosine theta multiplied by 2. And then, if we have Fy here, Fy, ano yung Fy natin? We have 40 sine of theta. Ano yung magiging distance that is in perpendicular to our point O? Diba ito yan? 8 feet. 8 feet. Then, pag tinulak natin yung ating 8 feet, yan, Fy din yan. Pag tinulak natin yung ating 8 feet, it will create what? It will create iikot yan into what manner? Clockwise motion. Kaya positive pa rin yan. 40 sine theta. And then the distance in perpendicular will be 8 feet. Okay? So, simplify natin. We have here 80 cosine theta plus 320 sine of theta. So, ang sabi dito, find the maximum moment about point O. About point A. Maximum moment. Therefore, application na ngayon ng maxima, minima. Okay? Maxima, minima. So, we will have the derivative of our moment in terms of what? Theta. So, we have dm divided by d theta is equal to 80. Ano yung derivative ng ating cosine? We have negative sine theta plus 320. Derivative of sine theta is what? Cosine theta. Cosine theta. And sabi natin kanina, maximum moment. Maximum moment. Therefore, maxima minima, it will be what? Equal to 0. So we have 0, negative 80 sine theta plus 320 cosine theta. Okay, so transpose natin sa kabila. So we have here 80 sine theta is equal to 320 cosine theta. So divide natin yan ng 80, then tsaka 80. And then transpose natin sa kabila yung ating cosine theta. Therefore, it will become sine theta divided by cosine theta is equal to 320 all over 80. Try natin dito. Sine divided by cosine is what? Tangent, diba? Tangent theta will now be equal to 4. Therefore, theta is 75.96 degrees. So to be able to produce the maximum moment, the theta must be 75.96 degrees. Okay, so yan na ngayon yung direction theta na hinahanap sa problem. And next is to compute for the maximum moment. Maximum moment. So ang gagawin lang natin dyan is to substitute, let's say this is the equation 1. Substitute equation 1 with theta is equal to 75.96. So we have here 80 cosine of 75.96 plus 320 sine of 75.96. Therefore, the moment at A will now be equal to 75.96 plus 320 sine of 75.96. So it will be equal to 329. 85. Ano yung magiging unit natin? We have pounds. Okay, pounds, inches. Okay. So this will be the final answer. Okay. Moment at A will be 329.85. Therefore, that is the maximum moment if we have a theta is equal to 75.96 degrees. Okay. So proceed na tayo sa last example for this part. So determine the total moment of all the forces about point O. Determine the total moment of all the forces about point O. So meron tayong apat na forces dito, and we will need to find the total moment acting at our point O. So pangalanan natin yan. We have here F1, F2, F3, tsaka F4. Okay? So for F2, kailangan nating hanapin yung equivalent component or force components of our F2. So this one, what is this one? We have 160 sine of 30 degrees. 30 degrees dito. So hinahanap natin yung x component. Therefore, we have 160 sine of 30 degrees. 160 sine of 30. So this is 80. Okay, 80 Newton. And then dito naman yung kanyang Fy, we have 160. What? 160 cosine of 30 degrees. And that is equal to 160 cosine of 30 degrees. So this is 138. 138.56. 138.56. Buray na natin yan. This one is 80. Okay, so alam nyo naman na siguro paano kumuha ng component, ano? So we have here 80 Newton, and then dito naman is 138.56 Newton. And then this one, okay, given naman yung kanyang slope. So this one, 3, 4, hypotenuse will be 5. 3, 4, 5 square root of 3 squared plus 4 squared. So this one, we have 150. We have 3 all over 5. We have 90 90 Newton. And then this one, what? We have 150 4 all over 5. 150 4 all over 5 is 120 Newton. Okay. 120 Newton yung kanyang X component. And then 90 naman yung Y component. So this one is 90 Newton. This is what? 120 Newton. Okay. So, okay na tayo sa mga forces that is acting with slope or angle. It's time to compute now for the moment at point A. Moment at point A equal to F1 plus F2 plus F3 plus F4. And then, of course, wag natin kalimutan yung kanilang mga distances in perpendicular to our point O. So, F1D 1 plus F2 D2 plus F3 D3 plus F4 D4. Okay. So, natin yung F. Unahin natin yung F1. F1, we have 180 Newton. So, the distance in perpendicular to our point A is, distance, 180 Newton. Perpendicular is this distance. This is equal to, ilan to? The overall length of this one or width of this one is 300 plus 200, 500 millimeters. So 500 minus 250. So this is 250 millimeters. 180 and then distance is 250 millimeters. It will create what? A clockwise motion. So itutulak natin yung 180 Newton dito sa distance na to. So yung distance na to will create a clockwise motion, diba? So we have here positive. Next one sa F2. This one is our F2 kanina. So gagamitin natin yung component of our F2 kasi naka-incline yung ating force. Unahin natin yung F2x niya. F2x is what? 80 Newton. Ano yung maging distance in perpendicular to our point A? So ito yung ating force F2. Ayan, 80 Newton. So the distance is, ito yung distance. Ito yung distance. Yan na. So this is, what? We have here the overall length is 600 millimeters. So 600 minus 200. So we are left with 400. Okay. So we have 400 millimeters. Okay, so tapos na tayo sa X component niya. Proceed tayo sa Y component. So ito yung Y component ng ating force F2. Ayan, 138.56. Wait lang. So yung 80 Newton natin, it will create what? Ito yung ating 400 mm, diba? 400 mm. So pag tinulak natin yung tip of 400 mm, it will create what motion? It will create, ito yung distance natin, it will create a counterclockwise motion. Kaya magiging negative yan. 80 minus, y minus, kasi it will create a counterclockwise motion. Okay? Next, yung kanyang Fy. Yung kanyang Fy is 138.56. Ito yun. Ito yung distance na to, force na to, 138.56. So, ano yung magiging moment arm? We're creating a moment at this point. So, ano yung distance na yun? Diba ito yun? So, ano yung distance na yun? The distance will be 500 millimeter. 500 millimeter. And it will create what? Pag tinulak natin itong, like, for example, this one, the stick, tinulak natin, it will create a clockwise motion. Iikot yung ating stick into its clockwise motion. Kaya positive yan. Okay, so tapos na tayo sa F2. Proceed naman tayo sa F3. So yung F3 ulit natin is composed of X and Y component kasi naka-incline siya. So unahin natin yung F3X. Our F3 is 120 Newton. 120. Ano yung magiging distance in perpendicular to our point A? Diba ito yan? Ayan. Distance na to. So it is 600. 600 millimeter. So, pag tinulak natin yung 600 millimeter using our force 120 Newton, it will create iikot yung ating stick into I clockwise direction. So, we have here positive 120. Okay. Next, yung kanyang Y component. So, we have here 90 Newton. Ano yung magiging distance in perpendicular to our point A? Okay, diba ito yan? Itong distance na to. Or, what? 300 millimeter. 300. So, pag tinulak natin yung 300 millimeters, ito yung distance of 300. Parehas lang yan. Kahit saan kanyo mag-refer. Pwede dito, pwede dito. Okay. So, pag tinulak natin yung force na 90 Newton, yung ating stick will create to move into a clockwise direction. Kaya positive pa rin yan. Okay. So, tapos na tayo sa F3. Proceed na tayo sa F4. So, ito yung F4 natin. We have 180 Newton. Ano yung magiging moment arm? What is the distance? Diba ito yan? Perpendicular. Yung distance na to. So, that is 250. So, pag tinulak natin yung stick na yan, it will create a counter-clockwise direction. So, ikot yung 250 millimeters natin into A counter-clockwise direction. Kaya, minus. Okay? So, summing up all the forces with their distance, we have 138.56 divided by 500 plus 120, 600, 90, 180 of 250. So our answer is 136,820 Newton that millimeter. So positive, so clockwise yung direction. So we have 136.82 Newton dot millimeter. Or if you want to express that into Newton that meter, we have 136.82 1362, sorry. 136,280 pala. 136,280. So I have 136.28 Newton that meter in clockwise direction. Okay? So this will be our final answer.